Ow. Hi, my name is Sebastian Palacios, and today I'll be fixing one of the problems I just had, which is not knowing where the door frame is. To further analyze why did I hit my head against the door frame, we firstly need to know why did it happen. Obviously, there was no light. Where was I going? So the lack of light is the So now with this solution in mind, we just have to know how can we turn on the light whenever I need to use it. I created a solution using a servomotor and a photoresistor, and of course the Arduino. So how the system works is the photoresistor is gonna be close to a window. When the window receives sunlight, this is gonna send a signal to the Arduino, and the Arduino is gonna power this, the servomotor. The servomotor is gonna move accordingly to how much light it receives. So it's gonna move to turn on the light whenever it is night, and vice versa when there is daylight.
So get your favorite drink and let's start.
You're gonna be needing the following materials: a photoresistor, a 9-gram 180-degree servomotor, a 220 ohm resistor. I found that you can use larger resistance resistors, so any might do. Some jumper cables, an Arduino Uno, a 9-volt battery. You can also connect to the outlet, so this one's optional. A breadboard, and of course a computer with the Arduino programmer. This is how my system works. First, from the 5-volt current, it does this turn, and it goes two ways: positive connection of the servo and photoresistor. The photoresistor continues its way down, and it splits into two parts. One that goes into the A3 port, which is the one that detects sensors of the Arduino. I just chose 3 because any number. And the other way is with a 220 ohm that I just told you about. This goes to the ground. From the servo, it has another connection to the Arduino called pulse. This is the one that's gonna tell the servo to move in directions by the Arduino. And of course, the negative goes to the ground as well. Now comes the fun part, to actually make it. First, you'll be needing, of course, breadboard and your Arduino. The first thing you have to do is to connect your Arduino to the breadboard. How do you do it? With these 2 jumper cables. One positive and the other going to the 5-volt I already told you about. This other cable goes to the negative. So this is ground and negative. Okay, nice. Second thing we're gonna be doing is, the photoresistor. I already connected it with 2 cables. It doesn't matter which one goes where. Positive and negative can be reversed with a photoresistor. So it goes from the positive here to here. I will tell you in a bit why did I do this. The next thing is the other cable that, remember, connects to the A3 port in the Arduino. So we're going to be doing that. In the same line, this in the middle, transport current this way, vertically, and these on the sides are horizontal. So if we want to have current from this part, we're going to be using this same horizontal line. This one connects to A3 in the Arduino. Nice. And to close the circuit in the photoresistor part, we're going to be using this 220 ohm resistor. Going from this, remember the same line, the vertical line of current of the photoresistor, to the negative, crossing this. So with this completed, the only thing missing is, of course, the servo. And it is pretty straightforward. The positive goes with the positive, negative, same, and the pulse will be connected to number 10, port number 10 here. So this will give the signal to the servo so it can move later with the program, And this is completed. So now with the next part.
Little dinner pause and then we'll continue with the coding. Now, to explain the programming, we first have to download one of the servo libraries. I got mine from the Arduino site, so you have to do that first. In the programming, first include servo H, just to include the servo into your system. Void setup, you have to declare your servo to attach to number 10, which is the port we just said. Serial begin is, as far as I know, it is the transference of data speed. So this is going to help us with the photoresistor. Now in void loop, which is the thing that's going to be constantly thinking and doing, first you have to look for A3, serial print ln, analog read, A3. A3 is the read that is you're going to be getting from the photoresistor. If the photoresistor, if A3 is having less than value 30, then the servo is going to write 60. 60 is the degrees, remember. Else, the servo is going to write 10. So now it's going to have 10 degrees. The position, it is the position. 30, I got it from up here, where it says serial monitor. In serial monitor, you can get the values of the photoresistor. And when you have a big value, it is going to be shown as a big number. So there's going to be light. It can be interpreted as that. If there is a low value, it means there is no light, or few of it. So yes, you can change this 30. Maybe you need more light, maybe you need less. This comes to your personal preference. And here it is, already hooked up to the light switch and to the window. I call my design the banana system. You can see the they look similar. For my personal situation, I had to use a longer cable for the photoresistor, as the window was a lot further away to the light switch. This is a video of the system working. As you can see, if I shine a light to the photoresistor, the light of the bathroom turns off. This can be perceived as if sunlight hits the photoresistor. When I remove the light, you can see that it turns back on.
So yeah, this has been my project. I hope that next time I want to go to the restroom, the light is switched on, so I don't have to hit my head against the frame. Thanks for watching, and if you want to do the same thing as I did, please do it. Yeah. Bye.